All right, let's jump right into this explainer, where we're going to demystify the life-saving emergency protocols hidden behind the scenes of heavy industry. We all rely on these massive, earth-moving machines and colossal storage systems to build our cities and feed the world, right? The scale of these operations is just awe-inspiring, but the physical risks involved, they're absolutely staggering. So today, we're focusing squarely on machinery safety, specifically emergency response and preparedness, and looking at what actually happens when the absolute worst-case scenario becomes reality.
3.5. Just let that number sink in for a second, because it completely shatters this comforting illusion we have of an instant rescue when things go south. We carry around this reassuring thought that if disaster strikes on a job site, we just dial 911 and help is there to pull us out in a matter of minutes. But in heavy industry, when you're dealing with really remote locations and incredibly complex entrapments, that is almost never the case.
3.5 hours is just the average time it takes to free someone trapped inside a grain bin. And get this, that clock, it only starts after the specialized rescue team has finally arrived on the scene. When you're trapped in 40-degree grain, your body heat is just rapidly sapped away, creating this severe, immediate risk of hypothermia. And on top of that, you're facing compression syndrome. The sheer crushing weight of the grain restricts blood flow, causing toxins to build up in your legs. It's a condition so severe, it can literally be fatal, even days after they get you out. So 3.5 hours? That is a terrifyingly long time to wait in those conditions.
I think grain bin safety expert John Lee really hit the nail on the head here when he said, if you're not in the bin, you can't get caught. It sounds simple, but preventing the disaster is always your absolute best survival tool. Emergency response is super critical, of course, but preparation and unyielding adherence to strict protocols before something ever goes wrong, that is what actually saves lives.
So here's our roadmap for today's explainer. We're going to cover the emergency action plan, what happens when heavy machinery fails, surviving high-risk environments, those invisible and deadly hazards, and finally, the golden rules of rescue. We'll start with the big picture regulations and zoom all the way down into split-second, life-or-death survival tactics.
Okay, part 1, the emergency action plan, the absolute foundation of survival. We're starting with the overarching rules mandated by OSHA because having a meticulous documented plan is the foundational blueprint for keeping workers alive when chaos erupts.
Look, OSHA's requirements here are strict for a reason. A compliant emergency action plan leaves absolutely zero room for guesswork. We're talking clear, mandated methods to report emergencies, exact evacuation procedures and escape routes, and strict post-evacuation headcounts so literally no one gets left behind. It also assigns very specific procedures for employees doing rescue or medical duties, along with designated emergency contacts. If you're operating a heavy machine or working deep in a mine site, knowing your exact role during an evacuation isn't just about ticking a regulatory box, it's the literal difference between a coordinated escape and fatal confusion.
Moving right along to part 2, when heavy machinery fails, or how we engineer against disaster. Imagine you're driving a massive underground loader, carrying tons of rock, and suddenly your engine stalls, or your main hydraulic pump just completely dies. What happens to your steering? Well, mechanical redundancies are what bridge that terrifying gap between a sudden failure and a fatal catastrophe. Without a backup, a stalled engine or a dead pump threatens a total loss of vehicle control. You're basically riding an unsteerable missile at that point. But thanks to modern emergency backup systems, like the ones engineered by Sandvik or HydroKit, the machine instantly detects that pressure drop. It automatically kicks on an independent electric motor pump. This vital backup maintains your ability to steer the vehicle just long enough to bring it to a safe, controlled stop. And if the operator senses an issue, they can even trigger it manually, right from the dashboard.
What's really fascinating here is the cross-industry inspiration. The fail-safes keeping a loader safe in a quarry or a mine are actually directly inspired by the backup steering systems used on massive ocean vessels. Maritime standards strictly require independent main and auxiliary steering gears, so if one fails, the other can still reliably guide the ship. That exact same redundancy philosophy is what's keeping heavy equipment operators alive on solid ground.
All right, part 3, surviving high-risk environments. Let's talk about the grain bin. We've talked about those agonizing 3.5-hour rescue times, right? So how do we ensure we never actually need that rescue in the first place? Entering one of these bins safely is a strict, absolutely unskippable sequence. Before anyone ever steps foot inside, you have to test the atmosphere. You need an oxygen level securely between 19.5 and 23.5% and zero toxic gases, like carbon monoxide from fermenting grain. Next up, you completely lock out and tag out all unloading equipment so conveyor doesn't accidentally turn on. Third,
The person entering equips a full-body harness firmly connected to a tension lifeline anchored outside the bin. And finally, you station 2 dedicated observers outside whose only job is to continuously monitor the person inside. Skipping just one of these steps, like say rushing in alone for just a second to clear a clump of grain, is the most common precursor to a tragic, inescapable engulfment.
Now for part 4, invisible and deadly hazards, specifically hydraulic injection. Let's dive into a completely unseen threat that operators face every single day. This is a hazard that often looks like a minor scratch, but is actually a ticking time bomb.
We are talking about a hydraulic fluid injection injury. This is a time-critical surgical emergency where high-pressure fluid breaches the skin through a wound so incredibly small it's virtually invisible. It usually happens when a worker is inspecting or standing near a ruptured hydraulic line. The fluid is under such extreme pressure that it acts like a microscopic needle injecting highly toxic fluid deep into the body. And because the initial puncture is so tiny and often completely painless, workers frequently just ignore it. They'll slap a Band-Aid on it and go right back to work. But that fluid is deeply toxic and it immediately begins destroying tissue from the inside out.
To put that danger into perspective, just look at these numbers. They dramatically illustrate exactly why this unseen hazard is so incredibly deadly. At general high pressures, you are looking at an amputation rate between 16 and 48%. But when you're dealing with heavy equipment pushing 7,000 psi or more, that fluid acts like a microscopic blade and the amputation rate approaches 100%. The internal damage to blood vessels, nerves, and muscles is just too catastrophic if it isn't addressed immediately.
So if you or a coworker ever experience this, these specific behavioral rules are your only defense against losing a limb. You must treat it as a surgical emergency. Call 911 immediately. Apply gentle pressure to control the bleeding. But whatever you do, absolutely do not attempt to squeeze the wound to push the fluid out. You will only force that toxic oil deeper into your tissue. And once you reach the hospital, you have to firmly demand a CT scan or an X-ray. A standard physical exam will almost always miss the profound deep tissue trauma.
Finally, Part 5, the golden rules of rescue. Let's look at power line strikes. Whether you're in an excavator, a crane, or a dump truck, hitting an overhead line changes literally everything in a fraction of a second. So, how do you safely escape a live vehicle? Well, if your machine contacts a power line, the absolute safest place for you is actually inside the cab. You are insulated. You call emergency services and you stay put. But what if the vehicle catches fire? You have to evacuate, but stepping out normally, like putting one foot on the ground while your hand is still touching the door, will kill you instantly by completing the electrical circuit.
Here is exactly how you survive that. First, you must jump completely clear of the cab. You cannot touch the vehicle and the ground at the same time. Second, when you land, you must land with both feet positioned tightly together. And third, you must shuffle or hop at least 30 feet away from the machine without ever separating your feet. Why? Because electricity ripples through the ground in rings of varying voltage. If you take a normal step, one foot is in a higher voltage zone than the other, creating a deadly step potential where the electricity travels up one leg and down the other. By keeping your feet together and shuffling, you neutralize that risk entirely.
And this brings us to probably one of the hardest rules to follow. If you see a coworker go down near a power line strike, you must stay back. Never attempt to rescue near a damaged line until the electricity network operator officially declares the ground safe. I know, it goes against all our human instincts to not run in and help a fallen friend, but electricity is invisible. Touching them, or even just running into that electrified zone, could instantly make you the second victim.
We rely on this heavy machinery every single day to keep our modern world turning. But when a routine task suddenly flips into a catastrophe, the difference between life and death isn't luck, it's preparation, rigorous protocols, and a deep, deep respect for the unseen hazards. So think about your own workspace, respect the strict safety measures we've explored in today's explainer, and ask yourself, if disaster strikes right now, how prepared are you, really?